Our next one is from Suba. He's an environmentally conscious scientist who is part of ALEC and is in his second year of his Masters of Industrial Research. He's been actively studying PFAS in the environment and consumer products since 2018 and plans to continue when he starts his PhD next year. Suba partnered with Eurofins as part of his Masters and has developed an accurate, reproducible and commercially viable analytical method to identify and quantify microplastics in surface water, soil, sand and biota. Welcome, Suba.
Thank you, Brad, for that introduction. So like Brad said, I've partnered up with Eurofins Testing Australia, and that's where I've been conducting research for my Masters. So to our knowledge, this is actually the very first study to detect microplastics in capped groundwater bores. So I'll give a quick recap on the two main types of microplastics, which are primary and secondary microplastics. And primary microplastics include nurdles and microbeads, which you will find in personal care products, while secondary microplastic particles are particles that have degraded over time by undergoing UV or mechanical degradation. So the general consensus is that a microplastic particle is sized between 1 micron and 5 millimeters. So it is important to understand the occurrence of emerging contaminants like microplastics in groundwater because it provides fresh water for 2 million humans globally every year. And in the bottom right, you can see that groundwater in Victoria is mainly used for agricultural. So for this study, we concentrated on the Bacchus Marsh Irrigation District, which is located 50 kilometers northwest of Melbourne. So this region was actually chosen for its high reliance of groundwater for irrigation, commercial and domestic use. And the groundwater flow follows the topography of the Lerderderg and the Werribee River. So these two rivers are the two main streams in the Bacchus Marsh Irrigation District. The aquifer at Bacchus Marsh is unconfined, highly permeable, and limited in size. So all this suggests is that it is very likely that the groundwater is well mixed. Lastly, the geologic age of this region is from the most recent geological epoch. For this study, we obtained groundwater from 7 bores across 5 sites. So 2 sites were nested bores at 2 different depths, and you can see these as 1 and 2 and 5 and 6. So we took samples in triplicus and analyzed a total of 21 samples, and each batch of 7 samples contained a method blank, a laboratory control sample, and a matrix spike. We obtained field blanks from 3 of the 5 sites, and these sites were chosen at random. And the aim of the study was to determine if the 8 most common polymers detected in the environment already can be found in capped groundwater bores. Once these samples were obtained, they were kept in a cool room until they were ready to be prepared for sample analysis. And all these samples were filtered and underwent an organic digestion with using 30% hydrogen peroxide. These were then shaken and incubated for 24 hours at 60 degrees. And then the following day, we filtered the hydrogen peroxide solution and the samples underwent a density separation. So all this did was to ensure that all the particles, all the microplastic particles had floated to the top of the vial. And then they were finally filtered once again using the overflow technique and transferred onto an IR reflective slide. So once on the slide, the samples were ready to be analyzed using Agilent's novel laser direct infrared imaging system, LDIR for short. So the LDIR would start off with 2 quick scans and highlight any particles on the slide, and it actually looks something like this. So once the LDIR has identified the location of these particles, the collaborative software will obtain a spectra for each particle and run it against the library and categorize them into the types and polymers and determine the size of the polymer as well. So the hit quality is determined on the match of the spectra. And for this study, we only reported anything above 8%. I've compiled all my method blanks and 3 field blanks together. And on average, there was 2 polycarbonates and 3 polyamides. The data for this study had been blank corrected using blank subtraction. There was 100% detection of microplastics in all the bores with an overall average of 38 microplastics per litre. So it had an average range of 16 microplastics per litre in bore 7 to 97 microplastics per litre in bore 3. There was 100% detection of polyethylene, polypropylene, polystyrene, and polyvinyl chloride, with polyethylene and polyvinyl chloride contributing 29 and 30% respectively to the total average sum of microplastics. The average size of microplastic particles detected in the study was 89 microns, with a size range of 18 microns to 491 microns. So as you can see at the nested balls of 1 and 2 and 5 and 6, they both had similar amounts of microplastics and had a very similar profile polymers in each of the nested balls. In regards to the morphology, only fibers and fragments were identified in the study, with 94% being fragments and only 6% being fibers. You can see examples there on the right-hand side. So I've chosen 3 specific sites to go into more detail. So these will be site 2, site 4, and site 5. So site 2, ball number 3, contained the most number of microplastics. So on average, it contained 52 polyvinyl chloride, 15 polyethylene, 12 polystyrene, and 7 polypropylene. So naturally, straight away, our eyes went towards the amount of PVC we detected in this ball. So as the balls were actually made from PVC, we initially thought this could be the source. But as each of these balls were constructed in the same material in the same year, we acknowledged that we would expect to see similar amounts of PVC at each of the balls rather than one particular ball. So with our understanding of surface recharge, we turned our attention towards the adjacent meat facility. And through person communication, I was able to confirm that they use cryovacuum to transport their meat. So cryovacuum is generally made out of PVC with a polyethylene coating. I wasn't able to confirm whether or not they use trays, but if they do, they're generally made out of PET and polypropylene with a polyethylene sealant. So it is important we note that this meat facility has been operating for over 50 years now. So if this establishment has or had its own on-site disposal area, residue from such products could have slowly leached to the soil profile and over time entered the groundwater system. Site 4, 1, 5, and 6. So this site was the second of the nested balls and was adjacent to a nursery. Like I said earlier, we saw similar amounts of microplastics at different depths with different amounts of each polymer, with similar amounts of each polymer, sorry, at each of the 2 balls. Overall, the most detected type of microplastic was polyethylene. And like I said in my previous slide, due to surface recharge, the most probable avenue of contamination could be from the nursery and the use of plastic mulch within the garden industry. So it is also generally well known that the garden industry uses organic amendments such as potting mix, which contain a variety of municipal waste streams, such as biosolids, which we all know already contain microplastics. The reason why I've included this slide, it was because it was the only ball that did not have any significant agricultural sites surrounding it. It was downhill from a residential area and uphill from an orchard. So the presence of microplastic at this particular ball can be considered to be background contamination. It could also be said that the presence of microplastic at each site, the presence of microplastic at each site could have been transported from sources from further away. So this ball is actually downhill from sites 1 and 2. So it could be assumed that microplastics could have traveled within the groundwater system and towards this site. Another possible explanation for this could be atmospheric deposition of microplastics on the soil surface, and over time, it going through the soil profile as into the groundwater system. So the 3 most possible avenues of contaminations are 1, movement through the soil profile into the aquifer, 2, during construction of the ball, and 3, contamination occurring during sampling through atmospheric contamination. But we actually eliminated the construction of the balls being a source, as they were all built with the same type of PVC in the same year. And like I said earlier, if this was the source, we would expect to see similar amounts of microplastic concentration and profiles in each of the balls. It is also a common practice to actually purge the balls before sampling, so which would have occurred each time these balls were sampled, and by now, the microplastic introduced during ball construction would have been removed. The atmosphere was also considered an unlikely source, as the bores were capped and these bores are accessed infrequently. And if particles had fallen in while uncapped or introduced while we sampled, it is likely they would just float on top of the water surface due to their low density. And we actually obtained water from a lower screening interval, which is why we actually hypothesized that the most likely avenue of contamination is percolation through the soil, as the average size of the microplastics identified was only 89 microns, with a range of 18 to 491. So this is very similar to a grain of sand, which on average is about 400 microns, which makes it entirely plausible that these extremely small particles had moved through the soil profile and into the groundwater system. So thank you very much for everyone who contributed to my study from the University of Melbourne, Eurofins Testing, Australia and New Zealand, and RMIT University. And yeah, thank you for everyone listening to my presentation.